ClickMyProject.com. Let us discuss our project. Our project title is Carrier Frequency Offset Estimation for CO-OFDM, the matched filter approach. Abstract: Coherent optical orthogonal frequency division multiplexing has been an attractive technology for long-haul optical communication system due to its high spectral efficiency. Many approaches have been proposed to estimate and compensate for the CFO, carrier frequency offset, in both wireless and optical communications. In this concept, a novel carrier frequency offset estimator for coherent optical orthogonal frequency division multiplexing systems using the matched filter. This proposed work, which discussed the performance and simulation results in the BLMFML, that is blind matched filter maximum likelihood, and DAMFML, that is data aided matched filter maximum likelihood algorithm, and it demonstrates the estimation error variance. The objective of this paper is to achieve the full range carrier frequency offset estimation with high accuracy. Also, this process shows the effective simulation results by these two algorithms. Flow diagram of the project. First, OFDM transmitter system. Here, the data streams are mapped to the corresponding information and symbols for different subcarriers with one OFDM symbol. It is then padded with a virtual subcarriers, which allows the system to easily accommodate for transmittive filters with a smooth transition band. Also, it is based by two types of modulation. That is, first, quadrature amplitude modulation, then phase shift keying modulation. In this modulation, the parallel streams are converted back to serial samples through the PS conversion and into a real-time waveform through a DAC, that is digital to analog converter. Then the baseband electric signal are modulated onto a light with an IQ modulators. Then the output signals are estimated by the carrier frequency offset. Here they use the three types of algorithm, which is proposed algorithm is data aided matched filter maximum likelihood and blind matched filter maximum likelihood. CRLB is an existing algorithm procedures. Also, the CFO estimate the error variance and signal to noise ratio in various decibel. Then OFDM receiver system. The system at the receiver ends OFDM signal is down converted to the baseband with a coherent receiver. It is sampled by an ADC, that is analog to digital converter. It transforms the parallel pipes by SP conversion and demodulated with the DFT. After passing through the equalizer and demodulator, the parallel subcarriers are demodulated and transformed back into the serial data bits through the PS conversion. Then the simulation is calculated by the number of modulation order inputs, signal mapping, and MQAM MPSK modulation, length of the serial input data at the transmitter, and the number of data subcarriers is calculated, and then waveform is generated without any distortions. Last, performance estimation. In performance estimation, SNR is an important factor for this process. We consider the time domain, and it is also defined as the ratio of average energy per transmitted sample in time domain to the squared error variance. Then estimation error variance is also one of the important factor in estimator. It is commonly used to measure the estimation accuracy and calculate the SNR ranges in decibels. The result, which shows the high computational complexity in proposed algorithm than the existing system. Also, CFO estimate the error variance and SNR with a high ranges, and it is evaluated in the performance calculation. Let us see the running procedure of the process. This is the Matlab command window, and run the source code in the current folder. Click on right button and click run. Wait for a few minutes to receive the output. This is our first figure, that is spectrum of modulation. X-axis subcarrier index and amplitude spectrum is Y-axis. This hypothesized signals which generates by zero padded with number of samples, and it denotes the variance in according to their number of subcarriers. It is our simulation graph, which is an 16 phase shift keying modulation. It estimates the error variance under carrier frequency offset, and also it depends upon the three types of algorithm, and this too is proposed, and CRLB is an existing process. And this is second simulation, which is an 16 quadrature amplitude modulation. It estimates the error variance versus zero padding vector, also denotes the specific ranges occur in the graph. This figure 4 is also estimate the error, and it is first decrease and then constant in the ranges. It is taken by an zero padding factors under carrier frequency offset. It is an MPSK graph. It is also plotted by using a three types of algorithm and estimate the error versus the zero padding factors. It may be constant ranges with various decibels, and it increases the shape of matched signals with original results. And this graph shows the M quadrature amplitude modulation, which increases the modulation order under the estimation error variance. Besides, the BLMFML is more sensitive to the complex compared with DAMFML, and the SNR of 2 decibels CFO estimation performance degradation is even more than 1 order. It is the main reason that of BLMFML we use the delta function with the reference signal. QAM can cause severe estimation error when searching for the peak of these matched signals. The simulation which shows the estimation error variance versus SNR. Here DAMFML shows the best estimation performance which perfectly reaches the CRLB. Schimet's method performs the slightly worse than the DAMFML but better than both BLMFML and blind deterministic methods. Under PSK modulation, when SNR is greater than 3 decibels and blind deterministic method shows the worst CFO estimation performance. After this estimation, the performance gain of DAMFML is 2 decibels in SNR compared to any other algorithm. This graph obviously shows that of SNR of 10 decibels with a 16 PSK modulation, DAMFML performs the best and blind deterministic algorithm performs the worst. The performance of BLMFML is worse than the Schimet's method. This is because blind deterministic algorithm estimates the CFO based on 3 test values, which is quite sensitive to the complex channel. This graph shows the estimation error variance versus carrier frequency offset under the only 20 decibels in 16 PSK and QAM modulation. The results which illustrate that the DAMFML algorithm can achieve the optimal full range CO estimation And these are the outputs and process involved in this project. Thank you.